Hi, I'm Elizabeth Anderson Bull from Morningside College. This is my research study on the effects of integrating next generation science standards into first grade literacy curriculum. The problem that I've seen as an educator and as a researcher is that students in the United States aren't receiving enough science instruction at school, and so they aren't growing in science in the way that they should be. Science content, experiments, and explorations bring about many skills, especially critical thinking and problem solving. And these skills aren't being mastered because the amount of science instruction has been cut down in the elementary school day. Two worldwide assessments, which United States students are a part of, the TIMSS and PISA, provide the data that proves that U.S. students aren't meeting the benchmarks and goals in the way that we would like to see them doing. My personal reasons for choosing this research is because I have seen firsthand that students aren't receiving the amount of time to practice scientific skills, critical thinking, and problem solving in the classroom, and it's not enough time for them to be effective in these skills. The new science standards are rigorous, and students need the time to explore and understand them. But unfortunately, science time is being cut down and overrun by the amount of time needed for literacy. Students in early elementary school are excited and eager to learn, especially about science, so that eagerness needs to be fed with learning opportunities. The teachers need to be creative in finding ways to bring science back into the classroom. The theme that I found in research is that science and the elementary students' day have changed. Many schools have implemented science, technology, engineering, art, and math practices into their day in order for students to be thinking in non-traditional ways. Unfortunately, the time and effort put into that STEAM or STEM implementation hasn't helped the students' scores grow in the way that educators had hoped and are continuing to hope in this implementation. A big change that has been implemented into the school day is the 90-minute literacy block. This time cannot be interrupted for any reason, even for outside interventions such as the specifically designed instruction for students with individual education plan goals, or for the multi-tier system of support, which provides interventions for all students. These 90 minutes take up a large chunk of the school day. Two studies were conducted prior to my study, and one was in a second grade classroom and one was in a fourth grade classroom. The second grade classroom used the 5E lesson plan, in which the teacher brought in science content for the students to use in their 5E lesson plan of engage, explore, explain, elaborate, and evaluate within their literacy classroom. The results showed that all the students grew in science regardless of where they began as literacy learners. A second study was conducted in 94 fourth grade classrooms. This study has more similarities to my study, as there was a control group and an experimental group to compare. The control group received their science and literacy learning as they always had, while the experimental group used science content within their literacy time. The students in the experimental group had higher science scores than the students in the control group. The information processing theory fits well with my study because of the work within our memories. In order for the student's sensory memory to be triggered with them, they need to learn their content at a deep level in which they use their information effectively, and they're exposed to it in different ways. Students learn in a variety of different ways, as we all know, and they learn in a variety of different paces. So the teachers must respect that the student's short-term memory abilities to process the information is different, and they need to learn that information in multiple avenues in order to move that then into their long-term memory. The purpose of this study was to determine if the next generation science standard aligned content in literacy allows students to learn that content at a deep, deep level, and then helping the students understand and use the content in a different way. My hypothesis was that the students who have the NGSS implementation in their literacy curriculum will have higher test scores in science and no change, or a positive effect on their literacy scores. The independent variables were the literacy and science content, while the dependent variables were the students and the student scores on science and literacy assessments. The result of this study can be that to help teachers and administrators make decisions about how to move forward so that science is being brought back into the elementary classroom. The participants in this study were 36 first grade students from two different classrooms. There were 18 students in each classroom, 50% male and 50% females, 98% Caucasian, and there were two students who were on behavior individual education plan goals. At this school, I used the Lucy Calkins Workshop Model Literacy Curriculum for my study, the STEMscope Science Curriculum, and the teachers used the Fast Early Reading Assessments. They needed a paper copy and a computer for recording purposes, and then the STEMscope's pre and post assessments as well. The students within this study didn't know that they were part of a study since their school day didn't change at all. The literacy block was the same for both, in which they had large group time and then small group time that was more individualized and differentiated. The difference in literacy was that the experimental group's content was science-based. When it came time to science, there were differences because the students in the experimental group had more time for experiments and explorations because they learned the content in literacy, while the control group needed to complete readings and discussions on the science content before moving into the experiments and the explorations. In order to analyze the data effectively, I conducted 4 independent t-tests. 2 were conducted to compare the literacy scores, and 2 were conducted to compare the science scores. And I compared the experimental group versus the control group on their pre-tests, and the experimental group versus the control group on the post-tests in both literacy and science. The results for the literacy, as you can see, the students were very statistically similar on the pretest given at the beginning of this study. The experimental group had a mean score of 17 and 89/100ths, while the control group had a mean score of 18. Their standard deviations were 1 point different, with the control group having a higher standard deviation. The post-test shows that there isn't a large statistical difference between the two groups, but the experimental group did have a higher mean score with a higher standard deviation than the control group. The mean score for the experimental group was 44 and 56/100ths, while the control group's mean was 43. The standard deviation of the experimental group was about 3 points higher than that of the control group. As you can see in the results of the t-test, there is not a significant difference between the two groups. The researchers' hypothesis was that the literacy scores would not be negatively affected as a result of this study, and that proved to be true. The results for science, as you can see, the students were statistically similar based on their pre-tests. The means of both the control and the experimental group were the same, but the standard deviation of the control group was larger than that of the experimental group. After the study, the post-test proved that the experimental group scored higher than the control group. The mean of the experimental group was 17 and 17/100ths, while the control group's mean was 14 and 78/100ths. The control group's standard deviation was more than a point larger than that of the experimental group. The t-test on the post-test proves that there is a significant difference between the two groups. This proved that the hypothesis was correct and that the students in the experimental group scored higher in science than the control group. There are implications for everybody involved in changing a curriculum. The students will be experimenting and exploring within science more than they had been in the past. They will be able to recognize that they are the learning that they complete in literacy by thinking deeply about the content and reading into more than just the words on the page, and then they're using that learning in their science time explorations. They will truly be using their learning from the books to learn in a more hands-on manner. The teachers need to have an incredibly strong understanding for both literacy and science standards in order for them to make the change in their curriculum. They need to find the connections between the two, where and how to fit them all into the curriculum in a way that the students will be able to work towards a mastery in both science and literacy. Teachers have a lot to bring into their literacy time, so this is going to be something that is going to be time consuming and take a lot of hard work from the teachers. Administrators need to be on board with the teachers 100% and provide a lot of support for them. They need to make sure that they have changed the budget to provide the books that will be needed in order to make the change in the curriculum. And they will also need to be able to give the teachers the time to work together to adapt their curriculum in order to meet the needs of the students. And last, there are some implications for families as well. Families need to be in the know with what students are doing so they can continue the discussions at home. By having a school day in which the science content is in literacy and science, the students are spending a large chunk of their day talking about science and working with their science. And the extended learning can come at home when the students are sharing what they learned and continuing to think scientifically about why something did or didn't happen in an experiment. There are quite a few different limitations as well. The timing of this current study was skewed a little bit because the post-assessments weren't conducted within the same week. That is something that would be beneficial for a future researcher to change, to have the post-assessments come within the same week. That is difficult, and that was something that I ran into with this study because of the timing of the winter benchmarking of the FAST assessments. This study was also completed during just one unit of science and one checkpoint period of the FAST assessments, so it would be beneficial for someone else who's doing this in the future to have more data than just one unit to compare. And something else to think about for a future researcher is, how is science content addressed when students are in a fictional unit in literacy? So we know that students aren't just learning about nonfiction when they're in literacy, and they're learning skills within fiction as well. So how will science be addressed during a fiction unit in literacy? Another limitation that came about through the study was with the small group guided reading. The teachers didn't coordinate through this, and they met the needs of their students as they always had individually. If this study were to be reproduced, it would be beneficial for the teachers to coordinate with one another and have similar genres so that the small group content wouldn't be a variable that needed to be addressed. The age of the students is also a factor for future researchers to consider, because not all first grade students are able to effectively write about their learning. The pre and post assessments in science require the students to write about their learning, and if that's not a strong suit for a child, there needs to be another avenue for the students to prove what they have learned. Writing about learning is incredibly important, but in this study, the researcher needs to prioritize what they want from the students, and for my study, it was to see what they had learned in their science content. Another limitation is that the students need to be randomly selected. It would be best for the groups to be within 15 to 22 students, and for those groups to not change for more than 1 or 2 students. So if there's a group of 17, it would be best for an experimental group, it would be best if the control group had anywhere from 15 to 19 students, so it wasn't a huge change in the amount of students between the two groups. Although the students need to be randomly selected, the two groups also need to be statistically similar to begin with in order to read that data effectively in the end. If the two experimental groups are very statistically different to begin with, it'll be difficult to determine if the variables that affected the final scores or if it was an outside source. This study had students receiving very similar interventions for both MTSS and SDI time, so that's something also to consider, what kind of content is being taught in or being used for those interventions as well. Treatment diffusion was another limitation that came about in this study and would be difficult. It would be a difficult limitation to avoid. The students in the experimental group are so excited to talk about their explorations and their experiments and fun things that they've done in science. And then they are unintentionally teaching the students in the control group who didn't have all that time to do the experiments and the explorations. And a lot of times the control group wasn't able to finish an exploration or an experiment, and they would talk to a friend from the control group student would talk to a friend from the experimental group, and they would find out what had happened. And so the sharing of the learning is always great, but during a study like this, it would be best if the unstructured time with the students being together would be limited between the control group and the experimental group, so that the experimental group students weren't unintentionally teaching the control group and therefore kind of skewing the results because of that. So these are the references used in this project that I have right now. Thank you for watching.